Okay, today let us see about the concept of relative velocity. Let us consider two objects A and B are moving in a straight line. A and B are moving in a straight line in x-axis or any axis, but they are in a same axis. They are moving with velocity V and VB. Then how will give the relative velocity? Relative velocity of B with respect to A is VB minus VA. Relative velocity of A with respect to B is VA minus VB. This is general concept. Okay, now let us consider these three graphs. In first graph, this is the xt graph, that is displacement time graph. Okay, here we can see the slopes are equal. So here also it is theta, here also it is theta. If their slopes are equal, then their velocities are also equal. That means they are moving in same direction, same velocity at certain distance apart. So what will be their relative velocity? Let us consider velocity of B with respect to A. VB minus VA. So VB is also VA only. Okay, let us consider VA minus VA. So it is 0. So in this case, if two objects are moving with same velocity in same direction, then their relative velocity is 0. Now let us consider for this case. Here we can very well see this slope is larger than this slope. That is theta 2 is greater than theta 1. That means velocity of B is greater than velocity of A. If velocity of B is greater than velocity of A, then VB minus VA is not equals to 0. Okay. What is this intersecting point? This intersecting point is nothing but this is the time at which they both are meeting. So that is this intersecting point. So initially A and B both were starting at time t equals to 0, but A is moving with so slower velocity, but B is moving with some higher velocity than A. So when it is moving, A is moving like this, B is also moving in a faster way. Then at one point of time they are meeting. Then B goes faster, then A is going again slowly. This time is the time which they are meeting. Let us see about this graph. Here we can say this slope is positive. That is velocity is positive, meaning let us consider that they are going in this direction. VA is going like this. But B's graph is negative, having negative slope. That means velocity of B is in this direction. So let us see. VAB, velocity of A with respect to B is velocity of A minus velocity of B. Velocity of A, okay, let us take velocity of A is positive in this right side, it is moving right side, so let us consider that as positive, minus velocity of B, it is in negative direction, so minus VB. So it is VA plus VB. So what we can say, here the relative velocity is, we are adding VA plus VB. When the two bodies are moving in opposite direction, then their relative velocity comes out to be like this. Let us see about two important problems on relative velocity. One is the problem of rain and man. It is observed that for a man in motion, the rain appears to be falling at an angle with the vertical. Suppose if rain is falling in this direction, but it seems it is falling in this direction, it is making certain angle with a vertical. If greater is the velocity of man, greater is this angle. If velocity of man, if suppose the man is moving in this direction, if he is moving with faster velocity, then greater is this angle. Angle with the vertical it will be going on like this. This can be explained on the basis of relative velocity. Okay, let us consider a man is moving with a velocity Vm in east direction and rain is falling vertically downwards with velocity Vr So we can say the relative velocity of rain with respect to man is, let us consider this as V capital R, and V capital R equals to VR minus Vm. That is, velocity of rain with respect to man is velocity of rain minus velocity of man. We are writing in vector form. It is like plus minus Vm. Okay. This is velocity of man. We want minus Vm, so we are considering its negative direction. So this we are considering in this negative direction. Velocity of rain is like this, vertically downwards. Velocity of rain with respect to man, that is nothing but the resultant of these two vectors. It is like this according to parallelogram law. This like this. This is velocity of rain with respect to man. Also, if this is velocity of man and in negative direction, then we can move this vector wherever we want. So this will also be minus Vm. This will also be minus Vm. Okay. Now, using Pythagoras theorem, we can say VR square equals to, that is VR square equals to VR square plus Vm square. This we can write. Also, we can write tan theta. Tan theta equals to opposite by adjacent. What is opposite? That is CB, adjacent is OB. What is CB? It is Vm, velocity of man. What is adjacent? Velocity of rain, VR. So theta equals to tan inverse Vm by VR. From this we can very well say, if velocity of man is greater, then theta is greater. This theta is also the direction at which he should hold his umbrella in order to protect himself from the rain. Let us see this question. Rain is falling vertically downwards with a speed of 30 meters per second. A woman on a bicycle is traveling with a speed of 10 meters per second. In what direction should she hold her umbrella in order to protect herself from the rain? With what speed does the rain strike umbrella? This is a simple question. Let us consider for a change. Velocity of bicycle is in this direction, and velocity of rain is in this direction as usual. So minus Vb we should consider. So we are considering this direction. This is not compulsory, we should take it like this. We can also change it. If Vb we are taking like this, then minus Vb will be like this. Okay, now we are considering like this. If this is velocity of rain and this is velocity of bicycle, minus velocity of bicycle, then velocity of rain with respect to bicycle, it will be like this, in this direction. Because it is the resultant of these two vectors, there is velocity of rain with respect to bicycle. This is theta. Now we can see tan theta equals to opposite by adjacent. So this is opposite, minus Vb by adjacent is velocity of rain. This is velocity of rain. There is 10 by 30, there is 1 by 3. So theta equals to tan inverse 1 by 3. So this is the direction in which she should hold her umbrella in order to protect herself. Now, with what speed does this rain strike umbrella? That is velocity of rain with respect to bicycle, as we have already seen. That is under root VR square plus Vb square. That is under root 30 square plus 10 square. That we are getting it as 31.6 meter per second.